Hi guys, this is O-level chemistry, paper 11, June 2019, question 11. In a volumetric experiment, 25 cm cube of 0.1 mole per dm cube sodium hydroxide reacts exactly with 20 cm cube of sulfuric acid. And the equation is given. What is the concentration of the sulfuric acid? Okay, so in order to calculate this, the first thing we need to know is in this equation, 2 moles of sodium hydroxide are reacting with 1 mole of sulfuric acid. So step 1, finding the number of moles of NaOH. The concentration of NaOH is 0.1 mole per dm cube. That means 0.1 moles are present in 1000 centimeter cube. How many moles would be present in the 25 cm cube of NaOH that was used? So this would give us 25 upon 1000 into 0.1, which is equal to 0.0025 moles. So now we have obtained the moles of NaOH, and according to the equation, 2 moles of NaOH react with 1 mole of H2SO4, which makes the moles of H2SO4 as half the moles of NaOH, which is half of 0.0025, giving us a value of 0.00125 moles of H2SO4. Now, the volume of H2SO4 given is 20 cm cube. So, we have 0.00125 moles present in the 20 cm cube of acid that reacted. So, we need to find out the concentration. So, we need to find out the number of moles in 1 dm cube, which is equal to 1000 cm cube. So, this would be calculated as 1000 divided by 20 multiplied by 0.00125, which gives us a concentration of 0.0625 mole per dm cube. So this answer makes option A the correct option for this question. Question 12. The reaction for the conversion of bromoethane to ethanol is shown. In an experiment, 10.90 grams of bromoethane is converted into 3.45 grams of ethanol. What is the percentage yield? And they've given us the MR of C2H5Br as 109. So 109 grams of C2H5Br will produce, the MR of C2H5OH is 46. So it will produce 46 grams of C2H5OH. And the question says we have 10.9 grams of C2H5Br, and we need to find out how much of it would be produced if it was a percentage yield of 100%. So this would give us 10.9 divided by 109 into 46. So we are left with a value of 4.6 grams if the yield was 100%. However, instead of 4.6 grams, the question tells us that we have 3.45 grams being produced. So we calculate 3.45 out of the potential 4.6 grams into 100, giving us a percentage yield of 75%. So this calculation makes option C the correct option for this question. Question 13. 1 mole of a sugar CH2O taken 6 times is burned. Which volume of oxygen measured at room temperature and pressure is required for complete combustion of the sugar? So the sugar is C6H12O6, which is glucose. So glucose burning in oxygen is respiration of sugar, right? Respiration. So C6H12O6 plus 6O2 gives 6 CO2 plus 6 H2O, the opposite of photosynthesis. So we have 6 moles of oxygen required to burn 1 mole of sugar. So if 1 mole of sugar requires 6 moles of oxygen, that means the volume would be 6 multiplied by 24 dm cube, because the volume of any gas at RTP is 24 dm cube for 1 mole. So these are 6 moles. So we multiply 24 by 6 and we are getting an answer of 144 decimeter cube of oxygen being required. This calculation makes option C the correct option for this question. Question 14. Which statement about the purification of copper by electrolysis is correct? A pure copper anode is used? No, the anode can be impure because if copper ions dissolve in the electrolyte, then only copper will be deposited at the it's the anode. Yeah, I'm right. Anode. So the copper would be dissolved in the electrolyte and it would be deposited at the cathode. So impure copper anode or pure copper anode, both can be used. However, this question is asking for purification of copper. So purification of copper means that the copper that we have is impure. So that impure copper would be placed at the anode and all the impurities will fall down as anode sludge. So a pure copper anode will not be used. Pure copper anode will be used when we need to copper plate something. But here purification of copper requires an impure copper anode. A pure copper cathode is used, yes, so that the copper that is reduced, the copper ions that are reduced are deposited on a copper plate and the mass of the copper plate increases. The color of the electrolyte fades throughout the process. No, because copper ions are going into solution and then depositing on the cathode. So no. Color will remain the same. And the electrolyte used is a solution of copper oxide in water. It's copper sulfate, aqueous copper sulfate, copper 2 sulfate. So the correct option for this question is option B. Question 15. Which negative ions are present in aqueous copper sulfate? So copper sulfate has the sulfate ions present and aqueous means water is present. So hydroxide ions from water are present. Copper 2 ions and hydrogen ions. This will be true if they were asking for the positive ions present. Copper ions only, they are positively charged. Sulfate and hydroxide ions, yes. Sulfate ions only, also hydroxide ions. So option C is the correct option for this question. Question 16. The diagram shows the energy profile for a reaction, and this shows that it is an endothermic reaction because the energy of the products is greater than the energy of the reactants. So if whatever they are asking, let's just work something out. The activation energy would be this, basically R to P. R to P is the activation energy, and R to Q would be the delta H, which would be positive because this is an endothermic reaction. Okay, let's see what the question is asking. Which statement about the reaction is correct? It is endothermic and the activation energy is P2Q. No, the activation energy is R2P. So statement A is incorrect. It is endothermic and the activation energy is P2R. Yes, we just figured that out. It is exothermic. No, and it is exothermic. No, and the activation energy is P2Q. No, and it is P2R. Yes. So option A is incorrect because of the activation energy. Option B is correct. Option C is completely incorrect, and option D only has the activation energy value correct. So this makes option B the correct option for this question. Question 17. The table shows the energy released by the complete combustion of some compounds. Okay. Which compound releases the least energy when 1 gram is completely burned? So the first thing we need to calculate is the moles of each compound. So that would be 1 divided by its MR. And then we need to calculate the energy that is released. So we will multiply the value of 1 divided by MR with the delta S value given in the table. So let's work this out for all the compounds. So for benzene, it would be 1 divided by 78 multiplied by minus 3270 giving us a value of minus 41.92 kilojoules. For heptane, this would be 1 upon 100 into minus 4800, which will give us a value of minus 48.00 kilojoules. For octane, this would be 1 upon 114 into minus 5510. This would give us a value of minus 48.33 kilojoules. And for propane, this would be 1 upon 44 into minus 2200, which gives us a value of minus 50.00 kilojoules. So now that we have worked out all the energy that will be given off when 1 gram of each compound burns, now we need to see which is the one giving off the least energy. So the least energy value here is minus 41.92 belonging to benzene, which is in option A. So the calculation makes option A the correct option for this question. Question 18. Three experiments are carried out in which the same mass of magnesium is reacted with the same volume of dilute sulfuric acid at room temperature. The magnesium is in excess. Okay. Experiment 1. Large pieces of magnesium are used. Experiment 2. Small pieces of magnesium are used. And experiment 3. Large pieces of magnesium are used, but the concentration of the acid is increased. Graph of the results are shown. So when a large piece of magnesium would be used, it would take greater time to produce the same volume of gas as experiment 2, because in experiment 2 the pieces are small, so the magnesium is in excess, so all of the acid present would react, but it would react more quickly because there is greater exposed surface area in experiment 2. So y is the graph for experiment 1 and X is the graph for experiment 2, because they're both ending at the same volume. However, the volume that would be released in experiment 3 would be greater because you've got a greater concentration of acid. So W is the graph for experiment 3. And that is exactly what they have asked. Which row is correct? Experiment 1 is Y. So C and D may be the correct options. Experiment 2 is X, which eliminates option C, and experiment 3 is W, which is also correct for D. Therefore, option D is the correct option for this question. Question 19. The equation show four reversible reactions. For which reaction would the equilibrium move to the right for both an increase in pressure and an increase in temperature? Okay, so pressure and temperature, we will have to see for which reaction would it move to the right. Okay, if you increase the pressure in experiment in A, the moles of reactants and products are the same, so the equilibrium will not move. So pressure will not cause the equilibrium to move. And since it is an exothermic reaction, an increase in temperature will shift the equilibrium backwards. So option A is incorrect. Option B, 4 and 6, 10 moles of reactants, and 4 and 5, 9 moles of products. An increase in pressure will shift the equilibrium towards the right because the number of moles of products are lesser than the number of moles of reactants. And since this reaction is endothermic, increase in temperature will shift the equilibrium towards the endothermic side, which is the right side. So option B is correct. C, now an increase in pressure will shift the equilibrium towards the left because there is 1 mole of reactant and 2 moles of products. And because this is endothermic, an increase in temperature will shift the equilibrium towards the right. So the temperature shifts the equilibrium towards the right, but the pressure shifts it towards the left, making this option incorrect. And D, 3 moles of reactants, 2 moles of products. Increase in pressure will shift the equilibrium towards the right because number of moles of products is lesser than the number of moles of reactants. And since it is an exothermic reaction, an increase in temperature will favor the endothermic side, which would be the left side. So equilibrium will move to the left. So the movement of equilibrium is towards the right because of change of pressure, but towards the left because of change of temperature, making option D incorrect as well. So as a result, the correct option for this question is option B. Question 20. Gas X turns acidified potassium manganate 7 from purple to colorless. Gas Y turns aqueous potassium iodide from colorless to brown. So basically, potassium manganate is being reduced and potassium iodide is being oxidized. Okay. What do these observations show about gas X and Y? Gas X. So if potassium manganate is being reduced, that means gas X is a reducing agent. So that eliminates options A and B, and we will continue on with options C and D. And since gas Y oxidizes potassium iodide, it is an oxidizing agent, which makes option C correct and option D incorrect. Therefore, the correct option for this question is option C.